Hello, welcome to my video tutorial. My name is Mr. B.B. Chaudhary. In today's session, we will have discussion on algorithm complexity. Friends, the word algorithm has a great significance in computer science. In algorithm, we write step-by-step solutions for a given problem, and then this sequence of steps are converted into any programming language instructions which we call program. This program's instructions executed by computer processor and it gives desired solutions for the real world problem. So here efficiency of your program depends on algorithms you created. Obviously good algorithm improves the efficiency of your program. Actually the purpose of writing algorithms is to solve the problems. Now we will see the characteristics of an algorithms. So there are major 5 characteristics as shown in slide: finiteness, definiteness, effectiveness, input and output. Now we will see one by one. Finiteness: if you trace the steps for finding the solution, your algorithm must finish within finite number of steps for all possible conditions or cases. That means if algorithm takes minimum number of steps and gets the final solution. Second property, definiteness: each step of algorithm must be precisely defined and each instruction must be clear and unambiguous. Definiteness means specifying the sequence of operations for turning input into output. Third property, effectiveness, means that all those steps that are required to get the output must be feasible with the available resources. It should not contain any unnecessary and redundant steps which could make an algorithm ineffective. Next property is input. Any algorithms can take 0 or more inputs depending on problem. Input data is provided and transformed during the computation and produces the output. Here well defined input is required. The last property is the output. So any algorithm should generate some output which is the result of some computations. Intended output must be expected here. So an algorithms can generate a single output value or more than one output depending on the problems. So it is must that output must be generated, otherwise there is no meaning for that algorithm. Now in the next slide we will try to understand the concept of analysis of algorithm, how the analysis of algorithms can be done. So analyzing algorithms means determining how efficient an algorithm is. As I said previously, algorithms are written to solve the problems. For example, sorting of numbers in array. So you have written algorithm. So as a performance of this algorithm depends upon the two factors, and these are the time complexity and space complexity. So time complexity means the amount of computation times consumed on any processor of the computer system to obtain desired output. It is called the time complexity. Then the space complexity means the amount of memory used, called the space complexity. That means the space allocated in the memory. Now we will see one by one in detail. The first, time complexity. Time complexity of an algorithm is the total amount of time required by an algorithm to complete its execution. In simple words, every piece of code we write takes some times to execute. Thus time taken by any piece of code to run its known as the time complexity of that code. Calculations of exact time is very difficult. However, a rough estimate can be made for calculating the time complexity. We have to identify the active operations or the active instructions in the programs. That means we only consider such instructions which takes some execution times. The operations like the assignments, declarations, comment lines, which are not considered as active operations and not used for calculating the time complexity. So here one more term that you should know, that it is a frequency count. Frequency count means how many times an active instructions will get executed is called its frequency count. Frequency count is a proportional to execution time. If there are more than one active instructions involved, then the sum of the frequency counts taken into consideration. The largest magnitude is considered, that is the only those statements having the frequency counts are considered. So here take the example of this polynomial, that is f of n equal to n raised to 4 plus 20n cube plus n plus 40. Now what is the time complexity of this polynomial? So first understand the basic concept how to calculate the time complexity of a given polynomial. So here the term with the highest order magnitude, that is n raised to 4, is considered, and this term determines the time complexity of the function f of n. Time complexity is expressed typically in the big O notation. For example, here it can be shown as O of n raised to 4. So there are also other notations, and this mathematical notations represents upper limit of scaling factor for an algorithm. For example, I will show you some pieces of code and how to analyze them to find out the time complexity. So I am not writing here the complete algorithms or programs. Take the example first here. So in this example, the loop executes n times. Actually it executes n plus 1 times because of it starts from 0, and it takes the one more executions to coming out from this loop. So here this particular loop takes the n plus 1's repetitions. Thus the statement a equal to a star b will be repeated or will be executed n times, okay, because actually it executes n plus see this example 1 here. The for loop will execute n plus 1 time, that is the thus the statement a equal to a star b will execute n times. So here the time complexity can be represented as a O of n. see the another example here. Here for loop, so in this example, if suppose the for loops starts with the n and condition I is greater than 0 and I decrements or subtracted. So here the loop is decreasing, then also the statement executes a equal to a star b n times. So here the time complexity will be the order of O of n. Take the another example of this for loops. Here the for loop starts from 1 and condition is I is less than n and I is incremented by 2. So this statement will not repeat the n times but half of the n times. That is, the loop repeats only n by 2 times. If I say function f of n equal to n by 2, then its order is again order of n. In this example, you are already familiar with this nested loop. Here first loop will execute n plus 1 time, that is like this, n plus 1 times, and inner loop will execute n into n plus 1 times, that is n into n plus 1 times. Thus the statement a equal to a into b will repeat n into n times. So this is nothing but the order of n square. Okay. So in the another example, there are the 3 loops which are again nested. So the first loop executes n so in this case the first loop executes n times and the second part, that is this one, will be executed n square times. Hence the sum of the frequency count n plus n square, which is a polynomial. So in this polynomial we will neglect the lower order terms and consider the frequency count as n square. That is, the time complexity of this particular piece of code is order of n square. So here with these few examples I have tried to explain you what is meant by time complexity and how to calculate the time complexity by showing some examples. So I hope you understood the concept. So thank you for watching my video.